All right, so the other day when we started this, okay, I was showing you how to make what's called a compound conversion. That is, convert something like 140 kilometers per hour to meters per second. Okay, and we said you basically just have to convert each unit separately. So if I have 140 kilometers per hour, I have 140 kilometers per 1 hour. Okay, and so what I need to do is convert kilometers to meters. Okay, if I want to get rid of the kilometers, I need to put the kilometers on the bottom of whatever of my conversion factor. Okay, this is my conversion factor here. There are 1,000 meters in 1 kilometer. I got to multiply by 1,000 to convert kilometers to meters. Everyone okay with that? Okay, and then I also need to convert the hours to seconds. In 1 hour, there are 3,600 seconds. I need to divide. Okay, on this one here, because it's not going to travel as far in 1 second as it is in 1 hour. Agreed? Right? Because I'm taking kilometers per hour and I'm making it meters per second. There'll be more meters, but less seconds. Okay? Everyone all right with that? Okay. Maybe it didn't sound right. Suddenly that didn't sound right in my head. Anyway, you're not going to go as many meters in 1 second as you go kilometers in 1 hour. Everyone okay with that? That's what I meant to say. Okay, so I'm going to multiply 140 by 1,000 and then divide it by 3,600. Well, the shortcut on this is to say, really, that's going to be 140 times 1,000 over 3,600. Well, I can get one conversion factor out of that. If I divide each of these by 1,000, I get 1 over 3.6. Okay, so if I take 140 and multiply it by 1 over 3.6, isn't that the same as doing this? Right? 140 times 1 is 140 divided by 3.6. If I want to convert something from kilometers per hour to meters per second, I simply divide it by 3.6. If I want to go the other way, I multiply it by 3.6. Okay? All right. So that's the first thing, is first convert the initial velocity in this question 2 meters per second. So we've just kind of showed you how to do that. So 140 divided by 3.6 is 38.9 meters per second. All right. The second part of the question is an acceleration question. Okay. What's the car's final velocity at the end of the 6.2 seconds? So it starts out at this velocity. It's going to accelerate at this rate for this long. All right. So they're giving me VI, A, and time. Okay, so I have VI, I have A, and I have T. What am I looking for? VF. All right, I'll give you a few minutes and I'll go over that one and then I'll kind of set you to work on that. Okay, so let's have a look at this one. We said we were given VI and we kind of calculated it, 38.9 meters per second. We're given A, 3.5 meters per second squared, and we're given the time 6.2 seconds. Okay, so acceleration equals VF minus VI over T, and we're looking for VF, so we're going to multiply both sides by T and then add VI to that, okay, and that will give us VF. All right, so that means 38.9 meters per second plus 6.2 seconds times 3.5 meters per second squared. Okay, and that should give us our 60.6 meters per second. Okay, any questions on how that one works? Okay, so keep going on the rest of the questions on there and we'll see if anyone has any questions, or I'll maybe pick a few at random here in a little bit. All right, so it's accelerated in a linear accelerator like the Large Hadron Collider. Okay, that's a particle accelerator. Okay, the acceleration is 800 meters per second squared, which is huge, or as Trump would say, huge. Okay, how long does it take to get the proton from rest? VI is 0. You're going to hear that a lot over the next 4 years. Just get used to it. Okay, and it gets to a final velocity of 2.5 times 10 to the 8 meters per second. So I've got VI, VF, and A. I'm just looking for T. All right, so T equals, okay, VF minus VI over A. All I do is switch A and T there by multiplying both sides by T. Okay, so sorry, I had T down here. I multiplied both sides by it, It came over here. I had A over here originally. I divide both sides by A. A ends up over here. Everyone okay with that? All right. So T equals then 2.5 times 10 to the 8. You have to treat that like you did Avogadro's number in the last unit. You got to put it in brackets, use the EXP, okay? And since it's minus 0, that makes it easier, okay? Then divide that by 800. Guys, this is why things like the Large Hadron Collider are so big, okay? They have to accelerate things over huge distances in order to get them up to the speeds they need to smash them together and make like Higgs boson particles and things like that, okay? Right? That's why they're so expensive to build and need super smart people around all the time. All right. Okay. Any other ones? All right. Work a little bit on that on the Need for Speed lab over the weekend. Okay, get that done. I won't be here on Monday. Okay. I'm on the physics trip on Monday.